So far this chapter we've been looking mostly at protons and electrons, and we haven't talked a lot about neutrons. And the reason for that is when you take a closer look at atoms, you can have the same element, and you will find that within all the atoms of that element, you will have some atoms that have a different number of neutrons. So for example, carbon. The periodic table tells you the atomic number of carbon is 6. So every atom that has 6 protons must be a carbon atom. So you could have one carbon atom and you'll find it has 6 protons. If we are talking about a neutral carbon atom, we know it has 6 electrons. And it turns out that atom might have 6 neutrons. So the mass of this atom is going to be different than the mass of another carbon atom which has 6 protons and 6 electrons, but it exists with an extra neutron, with 7 neutrons. So what we call these atoms that have different number of neutrons is the term isotopes. So the red atom would be one isotope of carbon, and the blue would be a second isotope of carbon. And it turns out that carbon has a third isotope, which has 8 neutrons. So to distinguish those, one way to do it is by using the mass number. The mass number is abbreviated with a capital A, and the mass number is the sum of the heavy parts of the atom, which were the protons and the neutrons. Remember, electrons are very, very light. So the red isotope of carbon would have a mass number of, we're adding together protons plus neutrons, 6 plus 6 is going to be a mass of 12. And the way you could see this written is the symbol from the periodic table and then a dash and then the mass number. So that would be called an atom of carbon 12. The blue isotope would have a mass number of 6 protons plus 7 neutrons, gives us 13, so we would call that an isotope of carbon 13. And then the last one has a mass number of 14, and we're going to call it C14. Writing it out this way doesn't give us as much information as what's called a nuclide symbol. The nuclide symbol has 4 parts to it. The main part is the symbol from the periodic table, and then we have a superscript to the right, which we've seen before. That's the place where we put the charge. But then we also have a superscript to the left and a subscript to the left. The superscript is where we put the mass number, and the subscript is where we put the atomic number. So for example, let's say we wanted to write the nuclide symbol. If we know we had 31 protons, 28 electrons, and 40 neutrons. So the first thing to look at is the number of protons. That's our Z value. So if Z equals 31, we can go to the periodic table and identify that that's the element gallium, capital G, lowercase a. So that's the main part of our nuclide symbol. The charge, the superscript to the right, remember, is the difference between positive charges and negative charges. So 31 positive protons, 28 negative electrons gives us an overall net value of positive 3, and we write the charge. Remember, the 3 comes first and then the positive sign. The left-hand side, superscript and subscript, The subscript we get from the atomic number Z, so that's just a 31 again. The superscript is the mass number, which remember was protons plus the neutrons, so that's a total of 71. So this would be the nuclide symbol for that atom. The next example, 8 protons, tells us from the periodic table that we're dealing with oxygen. If we had 8 protons, 6 electrons, that's going to be a net positive 2 again. And we know the atomic number for oxygen is 8, and we know the mass number is protons plus neutrons, that's 16. Now, oxygen, remember, is a nonmetal, so this is not a very likely ion that you're going to see. It'd be much more likely for you to see something from the periodic table. We can predict what kind of charge it should have. Oxygen is in group number 16. Last digit was 6. Subtract the magic number 8 and you get a negative 2. So if I give you the nuclide symbol of this would match what we would predict from the periodic table much more closely than the positive 2 cation. Oxygen would be much more likely to form a negative 2 ion instead of a positive 2 ion.